All right, in this video, I'm just going to be going over some review for the Chapter 11 test on sections 11.1 to 11.4. All the questions, I would encourage you to try them first and then watch the solutions on here. I think that'll be the most beneficial for you, is to try them before just watching me do it. So I think that's the best way to practice. Okay, so hopefully pause the video here, give this one a shot, and then go over it with you after that. All right, so any probability is just the favorable out of the total. So here, the total shirts, you just got to add them all up. So 3 plus 5 plus 2 plus 4. So I think that's just 14. And then we have to do ones that are green or a dress shirt. So I know there's a formula here for this, but I just like to do what makes sense. So like these ones don't count because they're not green or a dress shirt. These 5 count because they're green. These are dress shirts, so they count. And then these are both green and dress shirts, so they definitely count. So the ones that are green or dress shirts are, let's see, that'd be 11 out of 14. Okay, if you actually want to see the formula, you do the probability that it's green plus the probability that it's a dress shirt, and then minus the overlap, which are the green dress shirts here. So if you want to see that quick, we're going to erase this. And so the formula I would do, if we do the green ones first, we would do these 5 plus those 4, so we'd have 9 out of 14 for the green ones. Sorry for the poor handwriting. The dress shirts, these 2 are dress shirts, these ones are dress shirts. So you'd have 2 plus 4 dress shirts would be 6 out of 14 dress shirts. You'd add those up, and then you'd minus any ones that got counted twice. So these 4 are both green and dress shirts, so they got counted both times, so I'd subtract 4 14ths. Okay, and that would leave us with a total of 11 14ths. So it'd just be the same answer, just kind of a different way to do it. And I realize my handwriting is pretty bad here, so sorry about the poor handwriting. Okay, so the beginning questions I want to do now are just all about permutations, combinations, and counting principle. So my hints here that I think is worth mentioning quick is if you have multiple categories, then that's counting principle. Okay, so here you're picking one out of some colors, some trim, and some types of tires. So that's 3 different categories: color, trim, tires, right? And that's a hint you're going to do counting principle, right? If it's just one category, like just cards, and you're picking usually more than one, like here you're picking 5 out of the 52, then it's either going to be permutations or combinations. And if the order doesn't matter, like this one, then it's combinations. If the order does matter, permutations. Okay, so the hard part on these questions is really determining which situation it is. The rest of it is pretty easy. Like you can use your calculator, right? Do these buttons or just multiply the numbers together. So anyways, pause the video here and see if you can make some sense of this one. Okay, so this is multiple categories because you're choosing from a category called bread, a category called meat, and a category called cheese. Furthermore, you're picking one from each. So this is counting principle. You have 3 kinds of bread, 5 kinds of meat, and 3 kinds of cheese. Okay, and if you multiply, like for each bread, there's 5 meats, and after those 15 are made, you have 3 choices of cheese for each one. So just multiply all these together and you get 45 as our answer. Okay, so you're making a playlist of your favorite songs. You want to know different ways that they can be ordered or arranged in a playlist. Pause the video. Okay, so basically what I would think is I have 8 choices when I pick my first song, 7 when I pick my second song because I've already picked one, and then 6, and then 5, and then 4, 3, 2, 1, and the last time I don't really have any choices. So if you multiply those together, that is your answer, right? Which, if you remember from class, that's 8 factorial. So you can do that little exclamation point on your calculator. The other way to think of this is you can do this as a permutations because the order matters, and you're picking 8 out of 8. So you can also do 8p8, and that will get you the same answer. So on the calculator, those buttons again, if I just do math, and go to probability. Number 4 is my exclamation point, and then I can do 8 math probability and do permutations, 8 of 8, and that should be the same answer. So 40,320 different playlists here. Okay. All right, pause the video, see if you can make sense of it. Oh, you know what? You can't make sense of this because you got to know how many students are in class. So let's say the class has 30 students. All right, so this one should be permutations again because the order matters. So you're picking 3 out of 30, but you want to be first to get the $100 bill, obviously, right? So it'd be permutations of 30 and 3, and again, just do it on the calculator. I'm going to stop doing these on the calculator eventually, because hopefully you can figure that part out. 24,360. Okay, I think that's it for the permutations, combinations, counting principle. I think this is an and or an or just kind of do what makes sense, I guess. So pause the video, give it a shot. Okay, so when we start off, there's 14 socks, and then there's 5 that are blue. Okay, so this would be for the first sock being blue, but then we draw a blue one without replacing it. Okay, so now we want to know for the second sock, what is the chance we get blue? So now there's only 4 blue ones left out of 13 total, right? Because 1 blue one is taken out without replacement. So that would be that. That's the chance the second sock is blue, given that the first one has been drawn blue. Okay, pause the video, give this a shot. Okay, so if it's and, you just multiply them together. So we have a 41% chance of Q happening and a 9% chance of R happening. So the chances that both of them happen, just multiply them together. All right, and you get a very small chance, right? Generally with an and, the more things you have to do, the less likely all of them happen together. So in this case, our answer is about 4%, a little more than 3%. Okay, this is true. My mother-in-law sometimes likes to pick out my clothes. You can laugh all you want, but I hate shopping, so I don't mind that she does it. All right, pause the video and give this a shot. Okay, so this is another and because we want both the pants and the shirt are stylish. So I'm going to multiply their individual probabilities. So the probability that the shirt is stylish, okay, so that is 9 out of 16 shirts are stylish. And the probability that the pants are stylish, that is 1 out of 4 pairs. Okay, so I'm just going to multiply those together. So the chances that both are stylish is 9 out of 64, and then we should reduce this if possible, but I don't think there's anything that divides both of them evenly. So we are done 9/64. Okay, again, pause the video, give this a shot. Okay, so this is an or one again, and you can either do the formula. This is like the warm-up again. You can either do the formula or you can just do what makes sense. So I'm going to do the do what makes sense method because I kind of like that better. So there are, I think, 18 total students here, 5 plus 5 plus 4 plus 4, and they can be either glasses or uncool, right? So I'm just going to go through and say these 5 wear glasses, so they count. These 5 are cool and do not wear glasses, so they don't count. These are uncool and wear glasses, so they count. These are uncool, so they count. So they're uncool or glasses. The ones that underline are the ones that count. So add all those up, and that would be 13. So there's a 13 out of 8 chance that they wear glasses or are uncool. Okay, pause the video, give this one a shot. So again, this is an OR one where you can do the formula if you want, where you add them together and subtract the overlap. But if you just do what I'm doing, I'm going to say, okay, here's my lowercase letters. I'm just going to circle them all. Okay, and a consonant is a non-vowel. Non-vowel. Okay, so out of the ones I haven't circled yet, I'm going to say, okay, any of these consonants, and B is a consonant, C, D. So to be either lowercase or a consonant, there is 8 out of 10 that fit that criteria, which is as a decimal 0.8. Okay, conditional probability. Next, I encourage you to pause the video and give these a shot. There's 213 total people. Okay, so when you read these, the line means given that. So on this first one, this is a probability that they're male given that they play basketball. So when they say given that they play basketball, that means we're looking at all the basketball people, and that's our denominator. Usually whatever comes second is the denominator. And then the probability that they're male, given that they're a basketball player, is out of these 94 basketball players, 54 are male. So that probability is 54 out of 94. Next one says probability to play soccer, given that they're female. So given that they're female means I'm looking at all of these females, and I think that adds up to be 113. And out of those 113 females, how many play soccer? And that's 61. So again, the denominator is whatever comes second, all the females. Okay, last one's a little different. It's an and one. And again, I know we have a formula here, but I think I'm just going to kind of do what makes sense. So there's no given that, so my denominator is everybody. So that's 213. And out of those 213, how many are female and volleyball players? So that would be right here, female and volleyball. So it's 12 out of 213 are female and volleyball. Okay. Maybe skip that one. Let's do a probability dartboard one. So these are always good ones to try. This is actually taken from an ACT, so it'll be good practice for you. So pause the video, give it a shot. Okay, so just interpreting this a little bit, the big radius here is 10, and then each one inside of there is 2 less, so this would be 8, not 88, sorry. And then one in from there would be 6, etc., etc. Okay, and so the deal is Thomas has to hit at least 30 points. So he's got to be, man, I can't draw this, but he's got to be inside of here. Right, so he's got to be somewhere in here in order to win on his last start. Okay, so on a probability, you just do the favorable over the total. Okay, and for area of a circle, it's pi times radius squared for area of a circle. So the favorable is this circle here with a radius of 6. So it's just 6 squared times pi, so it's 36 pi. And I'm not going to do decimal here. I could multiply those together, but you'll see why it's kind of better without it. I'm just going to leave it as 36 times pi. And then for the whole thing, that radius is 10. So 10 squared times pi would be 100 pi. All right, so that's your chances of hitting, the probability of hitting inside the 30 ring, right? Getting at least 30 points. And so if you just clean that up, the pi's cancel, and it's just 36 divided by 100, which is 36%. Right, that's basically the definition of a percent is out of 100. So we have 36% chance of winning the game. All right, I got one more, but I'll make a second video. Thank you for watching.